Okay guys, so today we're gonna be solving another beautiful integral from the UNSW integration bee. It looks like this, and it is the integral between 0 and 2 times pi of the minimum of the sine of x and cosine of x all over the maximum of e to the cosine and e to the sine, that's all the x. I just love those integrals with kind of non-standard functions when you first of all have to think about what the integral even means before you can integrate it. And in this case, it means some fun stuff, yeah? So, first of all, what the minimum function is. So, this guy over there, what does it tell us? Well, it takes in two or more, but in this case, two values, sine of x and cosine of x, and just tells us which one of them is the smaller one. Yeah, so if there is an interval, let's say, on which sine is just, smaller than cosine, it spits out smaller values than cosine, then this function will give us the sine, yeah? And its graph is going to be just, this part of like the sine graph on this particular interval. On the other hand, this max function right there stands for maximum, and it gives us the bigger guy, yeah? It just spits out the greater value, the one that's bigger than the other one from the two values it was given, yeah? So if sine of x is smaller than cosine of x on that interval I just talked about, then, well, as e is greater than 1 and e to the greater power is greater than e to the smaller power, well, this function here is going to spit out e to the cosine because cosine is the greater guy. And so on that particular interval, our integral in question will be the integral from, well, some kind of an a, so the start point to some kind of b, which is the endpoint of that interval I just talked about, of just the sine of x all over e to the cosine of x dx. And well, this should give you guys an idea, because it means that if we find those intervals and we determine those intervals between 0 and 2 pi on which sine is less than cosine and cosine is less than sine, and just divide in the interval we are taking the integral over into those sub-intervals, then we will be able to drop those min and max functions that we don't even know how to integrate because they are, no, analytically say, for the sake of it. Well, and then we will be able to rewrite it as a sum of a few integrals that look like this. And this guy here, we know how to evaluate it. Just set u equal to cosine, and you've got your gu right there, or rather the negative du, but it doesn't really matter. So let's go on and do it. Well, on what intervals is sine less than cosine? And I would like to show you guys a graph right now that oh yeah, it did paste, lovely. So I've got a graph right here. I hope you guys can see it clearly. We've got two functions. The green one is the sine of x, whilst the blue one is the cosine of x. And so we can see that sine, which is this guy right here, is less than cosine on this interval we've got right there. It is less than cosine until they are equal to each other, and they are equal to each other for the first time at pi over 4. So 45 degrees, just imagine a right triangle with two 45-degree angles, something like this, yeah? Which is going to be isosceles, by the way, you see? So we've got pi over 4, or rather I should take a smaller, oh yeah, that was better. So pi over 4 that we've got right there. And then on the interval from pi over 4, well, and so on, we will get that cosine is gonna be the bigger guy. Well, that sine is gonna be the bigger guy, and then it's gonna flip once again at, well, it's gonna be kind of like how to say it, periodic at 5 over 4 times pi, so just kind of add pi to what you have right there, yeah? And so then cosine is just gonna take over all the way until we get to 2 times pi, and we don't really care about anything that happens after 2 times pi. We don't integrate that, yeah? So we actually got three different sub-intervals that we can integrate stuff over. The first one is between 0 and pi over 4. Then the second one is between pi over 4 and 5 over 4 times pi, and then from that guy from 5 over 4 times pi up to double the pi. And now if we just integrate over those three regions and we sum up those integrals together, we'll get the area under the curve that we wanted from the very beginning. So let's go on and do it. First of all, the integral between the interval between 0 and pi over 4. I'm gonna do it in yellow so you will have a so you know what interval I'm actually getting at. So the first one is going to be the integral between 0 and pi over 4. And on this interval, sine is the smaller one, and so we will get the integral of sine of x divided by e to the cosine of x dx. And now we add the second integral between pi over 4 and 5 pi over 4, so the integral from pi over 4 to 5 pi all over 4 of, now the cosine is the smaller one, and so we will get cosine of x all over e to the sine of x dx, and then plus, lastly, is going to be the integral between 5 over 4 pi and 2 pi, so 5 pi over 4 and 2 times pi, and now once again sine is a smaller guy, yeah? Sine is a smaller guy of sine of x all over e to the cosine of x dx. Lovely. And now how are we supposed to evaluate those guys? Well, just through the u sub, pretty regularly. Here we're gonna set our u equal to cosine of x. Now we're gonna get our du equal to a negative sine of x dx. And then as to the bounds of integration, whenever x is equal to a 0, then u is equal to a 1. And when x is equal to pi over 4, then u, which is the cosine of pi over 4, will be the square root of 2 divided by a 2. And that's the first u sub. Now the second u sub, maybe I will call it, I don't know, man, like y sub? I'm going to do a y sub here. I'm going to set y equal to sine of x. I'm going to get the dy equal to a cosine of x dx. And as to the bounds of integration, whenever x is equal to pi over 4, y is going to be equal to the square root of 2 over 2. And whenever x is equal to 5 pi over 4, god damn it, let me check it. And whenever x is equal to, what was it, 5 pi over 4, then y is going to be equal to negative square root of 2 over 2, and those are our bounds right here. And now for the third sub, let's call it t sub. I'm going to set t be equal to the cosine of x, so the cosine of x, and I'm gonna get dt equal to negative sine of x as well, just as I did earlier. And now whenever x is equal to 5 pi over 4, we're gonna get 5 pi over 4, we're gonna get t be equal to negative square root of 2 over 2, and whenever x is equal to double pi, we're gonna get shit, man. Cosine was the... No, wait. Cosine, yeah, 1. I'm not good at trig, yeah, I always do forget it. So it's gonna be equal to a 1. And so now I can just rewrite those integrals, this sum of integrals, as first of all, the yellow integral, that is between 1 and the square root of 2 over 2. This is kind of just flipped. I should be able to flip it later. It's gonna be negative this integral of 1 over e to du du. I can just use this negative sign to just flip those bars of integration, honestly. I don't quite like them because it's approximately 0.7 and this guy is 1, so I want to integrate from the smaller value to the bigger value. It just looks better, especially with that negative sign in the front that I can just kindly use. Yeah. And now this integral that is gonna be between negative square root of 2 over 2 is it? Oh, nah, shit. From square root of 2 over 2, square root of 2 over 2 up to negative square root of 2 over 2 is gonna be of, that was y, yeah, that was y, so 1 over e to dy dy, and then the last but not least, and as for the pink guy, it's gonna be negative integral between, and it's gonna be negative square root of 2 over 2 and a 1 of 1 over e to the t dt, and so right now we can just change the colors and get negative e to the negative u between square root of 2 over 2 and a 1, and then plus, or rather minus, or the plus? Minus? Yeah, it's gonna be minus e to d negative y between the square root of 2 over 2 and negative square root of 2 over 2, and then plus, and then my plus e to the negative t between negative square root of 2 over 2 and a 1, and so now as we evaluate it, we get negative e to the negative 1, then plus e to d negative square root of 2 over 2, and then it's going to be negative e to the positive square root of 2 over 2, and then positive e to the negative square root of 2 over 2. I'm getting mixed up already. It's going to be e to the negative 1, and then it's going to be minus e to the positive square root of 2 over 2. Now those two guys are going to cancel each other out. We're going to get 2 times, and it's going to be e to the negative square root of 2 over 2 minus e to the power of square root of 2 over 2. And now if you just kind of recall the formula for the hyperbolic sine of x, that was as follows. It was that sine h of x was equal to e to the x minus e to the negative x all over the 2. Well, this thing right here looks quite a bit like the sine h of x, doesn't it? We only have to divide this stuff by a 2, multiply by a negative, and then also, well, multiply by a 2 right there. So let's go and do it. We're going to write this entire thing as just negative 2 multiplied by e to the square root of 2 over 2 minus e to the negative square root of 2 over 2. It's going to be all negative 4, and inside here I'm going to just divide this entire thing by a 2. Remake those parentheses so they are a little bit bigger, and we get that this entire integral was equal to negative 4 times the hyperbolic sine evaluated at the square root of 2 over 2, and that's our final answer. So what did we do to arrive here once again? Well, nothing much really. We just kind of divided the interval that we were integrating over into 3 parts such that we knew what the sine of cosine was bigger on that interval, and we just divided this entire thing into 3 pretty easy to solve integrals and then just evaluate it. Though I made a mistake and I had to cut in the middle of the evaluation because I lost a negative sign, which is a standard procedure, I think, yeah. But this sign, I mean hyperbolic sign, just kind of appearing out of nowhere, I just love it. So I hope you guys enjoyed it, and see you next one. Bye.